Good afternoon, class. We are looking at intermediate algebra, practice test 4, module 4, which covers chapter 8, quadratic functions, and chapter 9, exponential and logarithmic functions. The session is being recorded. So we are looking at chapter 8, quadratic functions. Identify the vertex. Well, let's look at the general form of a quadratic function in vertex format. F of x equals a times x minus h, quantity squared plus k, where the vertex is located at h and k. Therefore, in a matter of comparison to this, we see for part A, the answer is 1, 2. And for part B is -3, -8. We want to find the x-intercept, the y-intercept, the vertex, determine whether the graph opens up and down, up or down, axis of symmetry, and so on. This is how you graph a quadratic function. So let's recap what we have learned about quadratic functions. Again, there are two forms, the form from the previous page, which was the vertex format, or this one, in many cases, this is called standard form, f of x equals ax squared plus bx plus c. And the graph of every quadratic function is called a parabola. When a is positive, it opens up. A is negative, it opens down. The vertex is the lowest point on the parabola that opens up, and the highest for the one that opens down. In other words, in this case, it opens up. This is the location of your minimum, and this is the location of a maximum. In order for you to find the vertex, x equals minus b over 2a, and all you have to do, find that, plug it into the original function and find the y, f of minus b over 2a. If you evaluate it, it gives you this formula, 4ac minus b squared over 4a. You don't have to memorize it, just minus b over 2a, find it and plug it in. Axis of symmetry is a line that divides a graph into two symmetrical halves. Notice we just found the vertex, the x coordinate is equal to minus b over 2a, and that is the equation of this axis of symmetry. Also, intercepts. When you graph x is 0, find y, y is 0, find x. Those are intercepts. And the domain happen to be all real numbers from negative to positive infinity. However, the range depends on the graph. If you're looking at this graph from the location of a vertex all the way to infinity, the y coordinate of that, when it opens up, when it opens down, from negative infinity to the location of a vertex, the y coordinate. So it depends on whether it opens up or down. So to graph this, we are going to go through the process that was just explained in the previous page. We set this equal to 0. We can factor it. It results in -1, x equals -1, x equals +5, which means we have two x-intercepts. It is important to see when we find those two, those are not the pairs, those are simply the x coordinates, and each one corresponds to the y coordinate of 0. So those are two x-intercepts. Y-intercept, simply put, if you look at this function and replace the x with 0, it results in -5. Vertex x equals minus b over 2a. When we look at the function, I hope you realize a is 1, b is -4, c is -5. So minus -4 over 2 times 1 results in +2. So the x coordinate of the vertex is 2. What is the y coordinate? Plug in. Replace the x with 2, and you end up with -9. Therefore, the vertex is located at 2, -9. So we found all the intercepts. We found the vertex. And we know a equals 1. Therefore, we know it opens up. Let's summarize the information we got in this table. And this last pair, I'm going to explain it in a moment. For now, you can ignore that. The rest of them, we already have them, for example, starting with the vertex, which is located at 2, -9, and we put it in. Then we have 2 x-intercepts. We put them in. We have a y-intercept located at 0, -5. And now I'm adding this pair for -5. The reason is because we have a parabola with the vertex located at 2, -9. The axis of symmetry therefore becomes x equals 2. And when we look at the location of this y-intercept, which is 0, -5, from 0 to 2, there are 2 units. If we go the same amount, 2 more, that means 2 plus 2, 4, we get to the same y value. That's how we get this one. So again, if you look at this y-intercept, which is here, 0, -5, compare it to the location of your vertex. Remember the vertex, you can draw, and I'm going to show you in a moment, the axis of symmetry, so it becomes clear now. Here's the graph. Here's the axis of symmetry with the equation of x equals 2. So this distance is 2. So is this distance. Therefore, this is located at 4, the same y coordinate, namely -5. And again, since a equals 1, we already know it opens up. What dimensions will yield the maximum area for a rectangle of perimeter 60 inches? Well, let's start mathematically as follows. We have a rectangle. We don't know the dimensions. Let's call them x and y. Therefore, the idea is to maximize this area. What is the area? The width times the length, x times y. And what is the restriction? We know P, which is 2w plus 2l, or 2 times w plus l, and now w is x, l is y, that is equal to 60. So we are maximizing the area given this restriction. We can divide by 2 and solve for y. You can divide by 2 and solve for y. Put that into the first equation, becomes a function of x only. Rewrite it, so this is 30x minus x squared, rewrite it in descending order. Notice this is a quadratic function, which means if we were to graph it, it's a parabola that opens down because a is negative. Therefore, the maximum occurs at its vertex, x equals minus b over 2a. This is b, positive 30. This is a, negative 1. And it results in x being 15. Plug it back into this one or this one. Find y, and the area is the product of x and y. So the maximum occurs when x and y are both 15. The length and the width are both the same 15, and the area is 225 h squared. Determine the number of real solutions. Remember, when we deal with the quadratic formula, which is in the form of ax squared plus bx plus c equal to 0, x becomes minus b plus minus the square root of b squared minus 4ac over 2a. What's underneath is known as the discriminant, underneath the square root. If it is positive, we have 2 real solutions. If it's 0, we have 1. If it's negative, we have no real solutions or 2 imaginary solutions. I hope everybody remembers that. So a quick recap: when it's positive, 2 real solutions. When it's 0, 1. When it's negative, none, which means 2 imaginary or complex solutions. And therefore, our first step is to write this in standard form, meaning bring them to the same side, and all you have to do, calculate b squared minus 4ac. Again, a is 2, b is 3, and c is negative 6. Let's calculate b squared minus 4ac. This is 9, this is 48. They add up to a positive value, and therefore there are 2 real solutions. There are 2 real solutions because we have a positive value. Solve the square root property. What is the square root property or principle? If x squared is a, where a is a real number, then x is plus minus square root of a. Therefore, instead of squaring, simplifying, bringing to the same side, put it in standard form, let's stick with that because of the format that it's given. Take a root of both sides. This is 2a minus 5. This is plus minus square root of 12. Now, plus minus square root of 12 is 4 times 3. I hope everybody remembers that. This is 4 times 3. So 2 square root of, let me just write that for you. The 4 comes out as 2. We move the negative 5. So we get 5 plus minus 2 square root of 3. We are almost done. Divide by 2. And you can leave it like that. This is the exact answer. We have 2 answers exact. If we could combine them, we should. If they ask for exact answers, you're done. If they ask for an approximation, then you use a calculator with a bunch of decimals. If you look at this question, this is also in the same format. We can take a root. The left side comes out, and the right side is plus minus the square root. And that is plus minus 2/3. So the right side is plus minus 2/3. We're going to move the 1/2, and it becomes negative on the other side. Because we must combine it. Unlike the previous example that we couldn't. Now we can. Negative 1/2 minus 2/3, negative 1/2 plus 2/3. I'm assuming everybody can add fractions. It results in negative 7/6, and in this case, 1/6. So again, just take a common denominator, which is number 6, okay? You have to take a common denominator in each case. How about this one? Again, because of the format, we can use the square root property by moving the 45. We take a root, the left side comes out of the square goes away, and the right side becomes square root of negative 45 plus minus. Now, how do we deal with that? This thing is the product of negative 1, 9, and 5. So 9 comes out as 3. 5 remains. Square root of negative 1 is represented with I. All we have to do, move the 4, and we are done. Can we combine them? No. There are two answers in the form of A plus BI and A minus BI. Solve by completing this square. So here's the steps. Could anybody read this for us, please?
Solving quadratic equations by completing the square. Ax squared plus bx plus c equals 0. A perfect square trinomial is a trinomial that can be expressed as the square of a binomial. X squared minus 10x plus 25 equals x minus 5 times x minus 5, or x minus 5 squared.
Perfect. This one, please.
Note that in every perfect square trinomial, the constant term is the square of 1/2 the coefficient of the x term, or b over 2a squared.
Perfect. Therefore, in order to complete the square, you take the following steps. You move the constant. You divide b by 2, square it, add it to both sides. And basically, you use the square root property. So as we look at this example A, the very first step would be to move the 7. We want to make sure the coefficient of x squared is 1. It is. We don't have to worry about that. Let's say it was 2. We would divide both sides by 2. But now we don't have to. So what is the value of b? Clearly number 6. Divided by 2, you get 3. Square it, you get 9. And that's the number we need to add to both sides. So let's do that. So the process is finding this number. Left side will always be x plus b over 2. When I say plus, whatever the sign of b over 2, the sign of b over 2 happened to be positive because it's positive 3. Whatever it is. So whatever this is, put it in here. Now, back in action, x plus 3 is plus minus square root of 2. And we move the positive 3 becomes negative 3, and we are done. Solving by completing this. Same here, we are going to use the same methodology. Negative 4 is moved. We divide also by 2. So the first thing is to move the negative 4. The next step is to get rid of the 2 because we want a to be 1. And when we look at this, notice this is b. The coefficient of the first degree term is b, negative 7/2. When you divide a fraction by 2, that means you multiply the denominator by it. Okay, so minus 7/4, and you square it, you get 49 over 16. So this happens in a split second. So quickly, b is negative 7/2. Half of it is negative 7/4, square it. Now we are going to add 49 over 16 to both sides. Now, what I want you to see is that the left side, remember what I said, it's x or y or z, any variable. In this case, the variable is z. And what comes inside, and we square it, b including its sign. So plus b happened to be -7/2. So you have z minus 7/2 squared. That's what's happening here. On the right side, you take a common denominator. So 2 times 16 plus 49. Okay, which is 32 plus 49, which is 81. So again, 2 times 16, 32 plus 49 is 81. Now take a root from both sides. Again, notice this, including the sign, comes in here. So the left side is z minus 7/4, and the right side is plus minus the square root of this guy, which is 9/4. So this is 9, comes out as 9/4. So plus minus 9/4. We are going to move the negative 7/4 and make it positive on the right side, which means now we are adding and subtracting. So 7 minus 9/4, that means minus 2/4, -1/2. 7 plus 9, 16/4, which is 4. So I'm assuming from here to here, there's maybe one more step. You have no problem with that. Quadratic formula was already discussed. Here's the formula: ax squared plus bx plus c equals 0. X is minus b plus minus the square root of b squared minus 4ac over 2a. So as we look at this one, a is 2, b is 4, c is 1, and all we have to do, plug in and evaluate. 16 minus 8 is 8. 8 is 2 square root of 2. Now, here's what I want you to pay attention to. There is a common factor of 2. You can't drop the 4 and 4. That's not how it works. You have to factor out the 2, because in essence, you have really 2 fractions. So you can drop a factor of 2. This becomes -2. This becomes plus minus square root of 2, and this becomes 2. In other words, if I were to write this, I would write it as 2 times -2 plus minus square root of 2, and therefore these two cancel each other as follows. And that's important to pay attention to. In this case, A is 7, B is 4, C is 3. We plug in using the quadratic formula that we have. We just plug in, and we need to evaluate. Simplification will end up giving us -4 plus minus the square root of -68. Now, -68 is the product of -1, 4, 17. So there are 3 numbers. 4 comes out as 2, 17 remains in, and square root of -1, we change it to I. Because some people may not recognize this I is not inside. Many times they put it in between. I don't like to put it in between. I want you to see this whole thing is considered B, because remember, A plus BI. But it's important for everybody to see I is outside. Now you take the common factor of 2 as you did here, and you drop the common factor of 2. This is your final answer. The next one, in order for you to use the quadratic formula, you put them on the same side. And now A is 2, B is 4, C is -5. Plug it in. You have to evaluate. This is 16. Minus and minus is plus 40, becomes 56. And again, 56 happened to be the product of 4 and 14. Again, 4 comes out as 2 and 14 remains. We take the common factor of 2 out. Again, let me show you 2 over here. By now, I think everybody is familiar with that, but in case 2 times -2 plus minus the square root of 14, and the common factor of 2 drops, and here's your final answer. So we can do by substitution, or we may recognize there's really no need for it. First of all, we bring everything to the same side, and we notice that r to the power of 4 is r squared to the second power. So if you stick with r squared, you want two numbers, the product is 15, the sum is -8. So you have those answers. I hope you realize that, although it can be done by letting r squared be something other than r, for example, x or u or m or y, any variable except r, do the math. This means r squared is 3. This means r squared equals 5. This means r is plus minus square root of 3, and this one plus minus square root of 5. We have total of 4 answers. For a case like this, it's a good practice to go with substitution. We let b to the power of -1 be anything other than b, for example, x. If you do that, please understand this means b to the power of -2 is x squared. If you square this one, you get b to the power of -2. This is x squared. So we can replace that and write it in this fashion. I have gone over 3 different methods of factoring for this. Using the PowerPoints, you can look at it. One easy way, you can do it by the trial and error. What is important, 6 is very easy to get, 2 and 3. 1 is easy, 1 and 1. And the reason both of them negative, because it's a positive sign and this is negative. You want to check the middle term. 2x times -1, 3x times -1, they must add up to the middle term of -5x. Therefore, x is 1/2, x is 1/3. You're not done, because we are interested in finding b. b to the power of -1, that means 1 over b. That means the relationship between x and b is that they are reciprocal of each other. So b is the reciprocal of this number, which is 2, and this number, which is 3. So I can write this as 1 over b. Or you can see that 1 over x equals b, however you want to put that. The fact of the matter is the two are reciprocal of each other. So how about this one? We bring them to the same side, and we let x to the power of 1/3 to be equal to m or y or z or x, any variable except x, in which case x to the power of 2/3 becomes m squared. So when we choose this, this becomes m squared equals 2m plus 3. Move everything to the same side. And this is an easy fact. We want two numbers. The product is -3. The sum is -2. We have the answers. M becomes 3. M becomes -1. Either 3 or -1. Now, we are interested in finding x. So x to the power of 1/3 is m. So what is x? Let's raise this to the power of 3 becomes x. This becomes m cubed, meaning x is 3 cubed, 27, or -1 cubed, which is -1. And when you get here, you really have to go back and check your work. I'll leave it for you to check to make sure you have the correct answer. Solve by substitution. For a question like this, even if they don't ask us to do it by substitution, that is the proper methodology, because you can raise this to the power of 2, multiply by 2, distribute, do the math. It takes longer. Instead, let this expression of 3x minus 4 be anything that you like, as long as it's not x. For example, if you choose y, this becomes 2y squared plus y minus 1 equals 0. You can easily factor it into y plus 1 times 2y minus 1. And set it equal to 0, y becomes -1, y becomes 1/2. Now remember, what is y? 3x minus 4. So we set 3x minus 4 equals -1 and we solve it. Also 1/2 and we solve it. So these are the two equations that need to be solved. I'm assuming everybody is okay with that. -4 goes to the other side. If you cross this out, that means what? 3, right? You're adding +4, so x becomes 1. And if you subtract, you're adding 4 here, you have 9/2, and you divide by 3, you get 3/2. So those are the answers. As always, you can check. Write a function that has the following solutions. That means x is given as square root of 3, x is given as negative square root of 3. We want to find the function. We said this equal to 0. So x minus square root of 3 is 0, and this one x plus square root of 3 equal to 0. Their product is also 0. And that gives us x squared minus 3 equals 0. So if you want an equation, this is the answer. If you want a function, this is the answer. This is the reverse process. Given the solution, given the roots, how do you find the answer? That's the concept. Reverse process. Solve and write the solution in interval notation. To do so, you have two choices. You can actually graph this and look at the parabola and figure out the portion above the x-axis, below the x-axis, and that does the job. However, we can do it easy by factoring and do the sign graph. So here's the factored form. And if we were to do the sign graph, it will be 0 at 1, it will be 0 at -5. So the way it works, x, this is a number line class, this is a number line from negative to positive infinity, x is -5. We're going to call this f of x. That's what I'm calling this expression f of x. Is 0. When it's 1, it's 0. So all you have to do, pick up a test point, and you can pick up a test point anywhere, here, here, and here, and check it out. One easy way between the two is 0. If you plug in 0 into this, you get negative. This sometimes is easier. So this becomes negative. The other two also, you can pick up a number, and the reason they alternate because the degree for each one is odd. So to the left of -5, so let me write those TPs, short for test points. Pick up -6 here, or so pick up 0 for here, pick up 2 for here, and you see this is positive, this is negative, this is positive. Going back to the question, we notice the question is asking for larger than or equal to 0. So positive here, positive here. These two regions is the answer. How do we write that? As follows. -∞ to -5, union 1 to infinity. The reason we use brackets, because there is a equality. Now, what is important for everybody to understand, this works always, and even if you are dealing with less than, then this would be the answer. Less than or equal, then we would have brackets. Even if we are dividing, it works the same way. So if you look at this example, x plus 5 over x minus 1, again, you use the same exact sign graph that we did with the following difference. Because 1 makes it 0 here, and that's fine and dandy, and makes the denominator 0 here, this is now changed with UD, stands for undefined. Other than that, we get absolutely the same sign graph. So what is the answer now? When we compare this to this, the answer would be the same, except because this is in the denominator, it cannot be 1. So over here, you change it to a parenthesis. That's why I wanted you to see both of them in this manner. Identical answer all the way except here. At 1, this is 0 and it's absolutely fine. At 1, this is undefined. So you want to be careful when you're dealing with the rational expression and the change that happens in that case. Could somebody read this one for us, please?
A model rocket will be launched from a hill 80 feet above the sea level. The launch site is next to the ocean sea level, and the rocket will fall into the ocean. The rocket's distance s above sea level at any time t is found by the equation s of t equals negative 16 t squared plus 64t plus 80. Find the time it takes for the rocket to strike the ocean.
Thank you so much. It does it when the distance is 0. So you set it equal to 0 and you solve. That means you factor out the negative 16 first. So first understand the meaning of that and why we set it equal to 0. Now this is an easy solve. We do the factoring and there are two answers, t equals 5, t equals negative 1. Can't be negative 1. So we have only one answer. It means the time it takes for the rocket to strike the ocean is 5 seconds. Would you mind reading this, please?
Frank drove a distance of 300 miles one way. The round trip took him 11 hours. If he averaged 10 miles per hour faster on his return trip, find his average speed going and returning.
Perfect. We are looking at what's called a motion problem, class. In the case of a motion problem, we should remember d equals rt. D is the distance, r is the average speed, t is the time. Therefore, coming up with a proper setup and proper table makes life easier. We are covering 300 miles. Either way, going back and forth, the distance is the same. So if we are driving 300 miles one way, that means we are coming back the same amount. That's the first thing. Total time is 11 hours. Okay. If he averaged 10 miles per hour faster on his return trip. So that means when we are going, we don't know the speed, but we do know when we are returning it's the same plus 10. So x and x plus 10. X and x plus 10. If we were to do it by system, we would call y, where y is x plus 10. The time it takes in each case, going back to this formula, when we know d equals rt, that means we know t is d over r. 300 over x here, 300 over x plus 10. It is important to know this requires two other formulas. T you can solve for it, r you can solve for it. And we know the total time is 11, therefore they add up to 11. When we come this far, we have completely translated this. We are almost done. We multiply both sides by LCD, which is x times x plus 10. This one is 300 times x plus 10. This one is 300 times x, and the right side is just 11 times x plus 10. We distribute and we simplify. So 300x, 3000, 300x, 11x squared, and that one is 11x. 110. This is 10, everybody. We have 600x on this side. and we're going to move everything to the same side. And because 11x squared is on the right, we want it in descending order. We put everything on the right side. That means you are going to subtract 600x, subtract 3000. You can solve it by any method you want. Factoring can do the job. Quadratic equation will do the job. There are two answers. Positive 50, negative 60 over 11 cannot be, so you cross that out. And if x is 50 miles per hour, then x plus 10 is 60 miles per hour, which means going, we were doing 50 miles per hour, returning, we were doing 60 miles per hour. And you can check by dividing 300 by 50, 300 by 60, add them up, they do become 11, which means you are checking and reachecking. In this case, the base of a triangle is 5 feet less than 3 times the height. We want to find the base and the height if the area is 25 square feet. So we need to know a few things. Number one, if this is the height, then the base is 3 times that minus 5. And the area, remember, it's always for a triangular shape, 1/2 base times the height. So 1/2 base times the height, we multiply these two numbers times 1/2, we receive 25 as the result. One easy way to solve this is to get rid of the 1/2 by multiplying both sides by 2. Distribute and move the 50 to the left. Factor. We get two answers. H is either 50 or negative 10/3. Sides can't be negative. The only acceptable answer, the height is 5 feet. What is the base? 3 times that minus 5. And you can always check with the area, which is 1/2 of 5 times 10, and it works.